This lesson will be about dividing polynomials. I'm going to show three different types of common division techniques that we have in different situations. The first one is when we have a monomial denominator. Now when we look at this expression, we first of all have to recognize that with this -1 exponent, it really means we're going to divide by it. So rewriting it, it would look like this. 5a to the 7th, b to the 4th, minus 30a to the 5th, b to the 3rd, plus 25a cubed, b to the 4th, and that's all over the denominator, 5a squared b. Now once we have a single term, no pluses or minuses in the denominator, that monomial, that means that we're going to separate each term in the numerator and put it over the denominator. So I'll separate this out and make it 5a to the 7th, b to the 4th, over that denominator, 5a squared b, then minus the 30a to the 5th, b to the 3rd, over 5a squared b, and then plus the last term, 25a to the 3rd, b to the 4th, over 5a squared b. Now, once we've got each one of those three terms, we now can simplify each of them as an individual problem. So the 5's reduce out here because the 5 over 5 is equal to 1. 7 minus 2 gives me a to the 5th. 4 minus 1 gives me b to the 3rd. This one, the 30 and the 5 reduce, and I'm going to be left with a 6. 5 factors here, 2 factors there. If I subtract, I get 3 factors left over. And then 3 factors and 1 factor leaves me with 2 in the numerator. And then plus 25 over 5, that will reduce down to the 5. And then a cubed over a squared gives me an a. 4 factors, 1 factor leaves me with 3 factors when I reduce that out. So this is the first step of when we divide by a monomial. We do 3 separate problems here with the 3 terms in the numerator, and that simplifies our division problem. Now we're going to move on to when we have a binomial or more terms in the denominator. Now with this problem, again in this case a binomial in the denominator, we can use what's called polynomial long division. We're going to make this look a lot like the old long division that was done back probably in elementary school when you worked on mathematics. We're going to take, this is our divisor, this is our dividend. We're going to take our divisor and we're going to divide it into the dividend, 4x cubed minus 6x squared. Now there's a missing term here. I've got plus 8x, but notice that there's no constant after that. So I need to make sure I put a placeholder for that missing term so that we account for it. So I'm going to divide this in. How you do this is you say 2x times what gives me the 4x cubed? The answer to that is we need to get 2 times 2 gives me the 4, and then x times x squared gives me that x cubed. Now I take and multiply this monomial times both of these and write it underneath. So we get 2x squared times 2x is 4x cubed. If these don't match, then we did something wrong, and they have to match. So 2x squared times 4 gives me an 8x squared. Now I'm going to subtract going down. So I'm going to put the parentheses just to remind myself to distribute through that negative. So 4x cubed minus 4x cubed is gone. Negative 6x squared minus 8x squared is going to be negative 14x squared. Now I bring the next term down, just like I used to bring down another digit in long division. You bring down the next term. Now I'm going to ask the same question. 2x times what gives me that negative 14x squared? Well, 2 times negative 7 gives me the negative 14, and then x times x gives me the x squared. So negative 7x times 2 is negative 14x squared. Again, they match. That has to happen. Then negative 7x times 4 gives me a negative 28x. I'm going to subtract going straight down. Okay, now when I subtract, these two are gone. 8x minus a negative is plus 28x. So I get 36x here bring down the 0. And I'm going to take 2x goes into 36x how many times? Well, I'm going to multiply it by 18. So I've got 18 times 2 gives me 36x. 18 times 4, that gives me, let's see, that'll be 72. Okay, and then I, again, subtract going straight down. No more x's left. 0 minus 72 gives me a negative 72. How I write my answer then is this quotient, which is what's above here. The quotient, 2x squared minus 7x plus 18, plus the remainder, negative 72, over the divisor, 2x plus 4. That's going to be a very common way we write answers when we have binomials or more. Just a reminder, and I'll write it up here, it's going to be the answer will be written as the quotient plus the remainder over the divisor. So in my problem, this is the quotient above the bar. This is my divisor out here that I'm dividing into that dividend, and there's my remainder. Now, what I'd like to do is show you a technique. This works for polynomials, and we can continue to use it, but because of the technique, it can get kind of cumbersome to go through the process. So we have another process called synthetic division that allows us to do these problems sometimes a little more efficiently. Let me show you an example of that. So with this last technique, synthetic division, involves the same types of problems that we were just doing where you have a binomial when you're dividing into it. But here what we're going to do is we're going to eliminate all the x's in the problem, all the variables, just work with the coefficients, and that's going to be an efficient way of using a pattern, a technique, in order to get our final answer. So the first step is to make sure everything is in order. So we need to have all the exponents, just like in polynomial long division, the last one, we have to have them in descending powers order. And these are, so 4, 2, 1, and then no x's. But I do notice then I'm missing an x cubed, so I'm going to have to fill in that spot as a placeholder. So the next thing I want to do is I want to take whatever the divisor is and whatever that number is, and this works, by the way, I can do it when there's a number in front of the x. That would be a different problem, an extra step onto this problem, where you'd have to, if this had been a 2, you have to divide each term by 2 in order to do that, or if it had been a 5, or let's say a 6 in front of the x, you'd have to divide every of the coefficients by 6 in order to do it this way. And that would work, but then it might involve fractions. So I'm doing it with a 1 as a coefficient. And then once you get 1 as the coefficient here, whatever that number is, you take its opposite and you put it in this little box over here as part of the technique. So I'll put a negative 5 over here. And then with the dividend, I'm going to take each of the coefficients without their variables. So I'm going to put 3 down. Again, I'm missing an x cubed, so I'm going to put a placeholder of a 0 because there's 0x cubed there. A negative 7, the 10, and then the 25. So all the coefficients without the variables. Draw a line and leave a space, leave a row here. The technique is bring the 3 down. The first one just comes down by itself. And now it's a process of multiplying and then adding. I'm going to multiply 3 times the negative 5, and I'm going to put it up in this spot here. So 3 times negative 5 gives me a negative 15. Okay, then I'm going to add those down, and I get negative 15 here. Now I take negative 15 times negative 5. When I multiply those two together, that's going to give me a positive 75. Okay, so add straight down, and that's going to give me a 68. Okay, now I'm going to do the same thing. I'm going to multiply and put it into this spot here. So when I multiply 68 times 5, let's see, I get 40 with multiplying that one. I get 30, so negative 340 for that. And I'm going to, because it's a negative, I'm going to add straight down. That gives me negative 330 for this spot. Now what I'm going to do is multiply the negative 5 times the negative 330, put it in this spot. So when I multiply that, let's see, I'll get a 0, and then 5 times 3 is 15. 5 times that is 15, a positive, and add that 1 remainder. I'm going to add straight down, and so I get 1675 as my remainder. These are going to be the coefficients, okay, the coefficients of the quotient in our problem, and this is going to be the remainder for our problem. So when I go to put it back into this form, quotient plus remainder over divisor, okay, I've already got the divisor. The divisor is just this x plus 5. And I know my remainder is 1675, okay? Now I'm going to take these quotient coefficients, and I'm going to start with 1 degree less than my original dividend was. So I'm going to make it, instead of a x to the 4th, I'll make it x cubed. So I'm going to have 3x cubed minus 15x squared plus 68x, and then minus 330, all plus my remainder over the divisor. So these are 3 different techniques for doing division with polynomials. The first one is when you have a monomial and you just separate it all over the denominator. The second, polynomial long division and synthetic division, can do the same types of problems, and they're used to do techniques when you have a binomial or more terms in the denominator. That helps you be able to divide those polynomials and come up with your result.